Hello everyone, myself Rujuta Vartak. This is our first unit in data structure using C. In today's session, we will see introduction to data structure. Before study data structure, we will first see data. What is data? Data is collection of raw facts. Data can be different type. It can be normal data, can be complex data. Simply data means information. To store this data and organize this data, we use data structure. Example, if we want to search a particular word from dictionary, it is easy because dictionary is organized alphabetically. So definition of data structure is a specialized format for organizing and storing data in a memory that considers not only the elements stored but also their relationship to each other. So all of you clear this? What is definition of data structure? Organizing and storing data efficiently. Now need of data structure. First point, it gives different level of organization data. Now all of you clear this data structure is used for organized data. Next, provide operation on group of data such as adding an item, looking up highest priority items. Data structure is used for adding a data and arrange this data priority wise. Next, to manage huge amount of data efficiently. Next, provide fast searching and sorting data. Data structure is used for searching data, sorting data, inserting data, deleting data, update data. Classification of data structure. Next is types of data structure. There are two types of data structure, primitive data structure and non-primitive data structure. Primitive data structure contain integer, float, character and boolean. This is our inbuilt data type. And non-primitive data structure are two types, linear data structure and non-linear data structure. Linear data structure contain arrays, linked list, stack and queue, and non-linear data structure contain trees and graphs. In next slide, we will discuss all these data structure types. Primitive data structure. Data structures that are directly operated upon the machine level instructions are known as primitive data structure. In this, use the inbuilt data type, integer, float, character, pointers, etc. Another type is non-primitive data structure. The data structures that are derived from the primitive data structures are called non-primitive data structures. Non-primitive data structures are user-defined data structure. The non-primitive data structures emphasize on structuring of a group of homogeneous, same type or heterogeneous, different type data items. Linear data structure. Linear data structures are kind of data structure that has homogeneous element. Means in linear data structure, the elements are same type. Next, the data structure in which elements are in sequence and from a linear series. In linear data structures, all elements is one by one. It is linearly, means sequentially. Linear data structures are very easy to implement since the memory of the computer is also organized in a linear fashion. Some commonly used linear data structures are stack, queue, and linked list. Next is non-linear data structures. A non-linear data structure is a data structure in which data item is connected to several other data items. Non-linear data structure is non-sequential. Nonlinear data structure may exhibit either a hierarchical relationship or parent-child relationship. In nonlinear data structure, the data is randomly connected, not connected in one by one. The data elements are not arranged in a sequential structure. The different nonlinear data structures are trees and graphs. Next is arrays. Why array is used? All of you know simple C programming. In simple C programming, if we want to store marks of 30 students, then we required 30 variables. But in array, we require only one variable and only give size of that variable. Okay, so in here we want to store 30 student marks, then we use size of array is 30. Okay, next, an array is defined as a set of finite number of homogeneous elements or same data items. Means if I store in 0 location 1, in 1 location B, in 2 location 4, in third location 8, and in fourth location character, then this is not possible because in array we can store only same data items. So here it means an array can contain one type of data only, either all integer or float point number or all character. Declaration of array is int is data type, a is array name, and 10 is size of array. Types of array is single dimensional array, two dimensional array, and multi-dimensional array. Next is stack. Stack is a linear data structure. In stack, push operation is used for insertion and pop operation is used for deletion. Now we see real life example of stack, that is a CD stand. In this CD stand, if we want to insert a new CD, obviously we insert this CD to the top of this stack. Second, if we want to take out CD from CD stand, only one option you take out from the top. So principle is last in, first out, you can say. So similarly, stack is work. We add first element, it goes on in 0th position, then we add second element, it goes on first position, and so on. And last element is called the top of the stack. Top is called a pointer. If stack is empty, then top is -1. If we insert a one element, then top is 0. If we insert second element, then top is 1. So on. So top is point out last element in the stack. Queue. Queue is also linear data structure. The real life example of queue is a queue of people at ticket window. If there is a train ticket counter and you are the first in queue and after you 5 person is there. So you are the first, you get ticket first. Then second person will get ticket. So hence follow the FIFO approach. Now see this in figure. Front and rear, this two pointer is used. Front is used for the deletion and rear is used for the insertion. If we want to delete element, then front shift to the 0 position to the 1 position. And if we want to insert one element to the sixth position, then there is shift to the sixth position. Here FIFO approach is used. FIFO means first in, first out. See here, if we want to delete one element, then which element is first delete? That is first inserted. Okay, here first inserted is 1, so we delete first element. Now all of you clear this? Q is used for FIFO approach. Next is the linked list. A list is a sequence of data structures which are connected together via links. Linked list consists of nodes. Each node is divided into two parts. First part contains the information of the element and second part contains the memory address of the next node in the list. See in this figure, there is node 1, node 2 and node 3. Node 1 contains two parts. First part is information, means data, and second part is the link. In this link, we stored address of node 2. If address of node 2 is 456, then this 456 is stored to the link of node 1. Main advantage of linked list is the size of linked list can increase or decrease at runtime. So there is no memory wastage. Next is the trees. A tree is a data structure consisting of nodes organized as a hierarchy. Tree is a hierarchical data structure, means non-linear data structure, which stores the information naturally in the form of hierarchy type. It represents the nodes connected by edges. Here in this figure, all nodes contain the information. A, B, C, D, E, F. These all contain information, and this is called a nodes. So first node is called as a root node, that is a, and then B and C is called as a parent node, and then D, E, F, G is called as a child node. The last node is called as a leaf node. We see here real life example. If A is a CEO of that particular company, and B and C under of that CEO, and D, E, F is a normal employee. If D want to contact to directly to the CEO, this is not possible. D is, if D is go through the B, and then B is contact to the that CEO. Okay, all of you clear this? In tree is non-linear data structure. This is a hierarchical data structure, and nodes are connected by edges. Next is graph. Graph is also a non-linear data structure capable of representing many kind of physical structure. A graph is set of vertices and edges which connected them. See in this figure 0, 1, 2, 3, 4. These nodes are called vertices, and 0 to 1, 0 to 4, these links are called edges. Okay, now see a real life example. If 0, 1, 2, 3, 4 are names of the cities, and edges between 0 to 1 tells us that there is road available, means direct road between 0 to 1. But there is no direct road available to 0 to 2. This is the meaning of graph in real world. So see here, V is called set of vertices and E is called set of edges. See here a definition of graph. A graph, G means graph, V comma E means set of vertices comma set of edges. Is set of vertices V and a set of edges E. So definition of graph is a graph is a set of vertices and edges which connect them. So here how to write set of vertices? V is equal to name of vertices, that is 0, 1, 2, 3 and 4. And next is E means edges is equal to 0 to 1, 0 to 4, 1 to 2, 1 to 3, 1 to 4, 2 to 3 and 3 to 4. You can write also 0 to 1, yeah, 1 to 0. If there is a direction between them 0 to 1, if there is a direction is given, then we only write 0 to 1. If direction is given 1 to 3, then compulsory we write 1 to 3. So all of you clear the graph. Next topic is complexity. Complexity of an algorithm is a measure of the amount of time or space required by an algorithm for an input of a given size n. In short, amount of time or space required to run the program. Notation of complexity is big O. There are two types of complexity, time complexity and space complexity. So let's discuss these two types in next slide. Time complexity. Time complexity is a function describing the amount of time an algorithm takes in terms of the amount of input to the algorithm. This time complexity means amount of time required to run the program. See here in this example, there is one for loop. I start from 1 to n. Okay, so n size is 8. So hello world is print n times. Okay, so the complexity of code is big O n. Now, if in this program we add another for loop, that is for j is equal to 1, j less than equal to n and j plus plus. So here is 2n. So here complexity of above code is big O n square. Next is space complexity. Space complexity is a function describing the amount of memory an algorithm takes in terms of the amount of input to the algorithm. In short, amount of space required to run the algorithm. See here example, int a is equal to 5, b is equal to 5 and c. So here are three variables. Okay, three integer variables are used, that is a, b and c. The size of the integer data type is 2 or 4 bytes, which depends on the compiler. Now let's assume the size as 4 bytes. So the total space occupied the above given program is 4 into 3 is equal to 12 bytes. Since no additional variable are used, no extra space is required. So here complexity is constant. So how to write that complexity is big O 1. If we take another program, in that we write for loop. Example, I is equal to 1, I less than n and I plus plus. So I is start from 1 and ends from n. So we require n number of variables. So here space complexity is big O n. All of you clear this? Now let's see about abstract data type. In short, we can call ADT. So we know what is data type. By using data type, we can declare a variable which can store a values. If we take int data type, it stores integer values. If we take float data type, it stores float values. So this integer and float, this data type is called inbuilt data type. But ADT is user defined data type. So let's see. First point is ADT is set of operations. So ADT is perform operations like insertion, deletion, sorting, searching in array, stack, queue, linked list. Okay. Second point is ADT specifies what is to be done, but how it is done is not specified. That is, all the implementing details are hidden. For example, we can drive a bike, but we don't know how the components like gear, clutch is implemented. So the background details are hidden. So this is called abstraction. Example, stack ADT have operations like push, pop, but we don't know how those operations are implemented. That is, implementing details are hidden. So simple. What is abstract data type? Abstract data type is user defined data type. It is set of operations and these implementing details are hidden. Next is operations on data structure. First operation is traversal. It is used to access each data item exactly once so that it can be processed. In traversal, we visit a data only one time. Next is searching. It is used to find out the location of the data item if it exists in the given collection of data items. Using searching, we search a particular data item. Next is insertion. It is used to add a new data item in the given collection of data items. Using insertion, we add a new data in the given collection. Deletion. It is used to delete an existing data item from the given collection of data items. Using deletion, we delete a particular data item. Next is sorting. It is used to arrange the data item in some order, that is in ascending or descending order in case of numerical data and in dictionary order in case of alphanumeric data. Using sorting, we sort a given data using ascending or descending order. Next is merging operation. It is used to combine two different data items into one file either after performing operation or as it is. We used merging to merge or combine data. Last is important questions. Okay, first question is what is data structure? State the need of data structure. Second, give the classification of data structure. Third, what is ADT, abstract data type? And last is explain operation on data structure. All of you write answers for this question. Thank you.